Tutorials by Decade. My name is Decade, and in this video we are going to add a player. We are going to move the player around. There's not going to be any animations yet. That'll be a future video. But we want to get you a player that moves around on the screen that you can control with the WASD on the keyboard or with a joypad or a gamepad or a game controller or whatever you want to call it. Before I get into any of that, make sure you subscribe, as I have videos like this coming out all the time. And at the end of the video, don't forget to like it. All that stuff helps me out, and I do appreciate that. With that out of the way, let's get some things going here. So one of the first things I want to do, I forgot to add this folder in last time. We're going to add a folder and call it input, and we're going to be using that here very shortly. Now, if you followed along the other videos, you should already have our characters in the game. If not, just drag and drop those into your sprites folder. Keep things organized. Try to keep them organized for you, but whatever works best for you, just make sure it's organized because things are going to get chaotic very quickly. With that being said, I did have 4 player characters. You can choose any one you want to use as your player character. I'm going with player 4 just because that's the original one. And the other ones are just variations of this one. So what you're going to want to do is you're going to pick the player character and then whatever number afterwards, and you're going to do just that sheet. Don't worry about the little square looking sheets. We will get to those eventually. But for now, pick whatever player character you want. And then as soon as you click on it, you're going to get everything over here. So what we want to do is we want to make sure that sprite mode is multiple, because there are multiple sprites on this sheet. We want to change the pixel per unit. We want to change that to 16. So if you hover over, it tells you right there how many pixels in the sprite correspond to 1 unit in the world. So 1 unity unit does not necessarily equal the number of pixels in this. So we want to set that to 16 to give it that retro Nintendo, Super Nintendo look. So put that on the 16. Filter mode, it's how it filters the image. We don't want it filtered, so we go with point no filter. And then compression, for this being a retro feel and the images themselves aren't that big, we don't need to compress. So we're just going to hit none, then we're going to hit apply. Once we're done with that, we're going to go to Open Sprite Editor. So anytime you have multiple sprites, you're going to want to do this. And you can kind of see these little white border outlines. So what Unity tries to do is it tries to slice up your sprite sheet. And it doesn't do a bad job, but the problem is, like you can see here, it took all 4 of these and just made it one sprite. We don't want to do that. We want to do this ourselves. So we're going to go up to here where it says slice. Type, we're going to change that to grid by cell size. And then in pixel size, X, we're going to change to 16. Y, we're going to change to 32. And now you're going to see these little red lines. And that's going to fit more to what we're trying to do. So then we're just going to hit slice. We can click anywhere outside of that. And now you'll see that we have uniform slices on all of our characters, or all of our character animations, which again, we're not going to do animation yet, but this will get us set up for that. So now that that's done, we're going to hit apply. And now that this is applied, we can close out the sprite editor. And you'll notice these little arrows. Anytime you do multiple sprites, you're going to get the, or a sprite sheet that has multiple sprites on it, you're going to get these little arrows. So what we're going to do is we're going to click on that arrow, and there is all of our sprites. We're just going to grab this very first one and drag it and drop it. And it automatically creates a game object over here. So the very first thing we're going to do is change the name of this to player. Now you can drop it wherever you want and you can keep it wherever you want for now. However, for the future, it's just easier if we just move this to 0, 0. Now, you're seeing all this stuff in the way. These are little gizmos. You can come up here and shut off all the gizmos if you want, turn them all on if you want, whatever it is that you want to do. That'll get rid of these little things here, but they are very, ignore my phone. They are very helpful though, so I like to leave them on, but if they get in the way and they're kind of annoying, that's where you would go to shut those off, is up here. But we're going to click on the player, and we're going to add some things to the player. So over on the inspector, as I mentioned in the last video, this is where you're going to change different things for each game object. We're going to add a couple components. So the first component you want to add is a rigid body 2D. So what this does is it applies physics to this object. So now we're able to move this object around. As you can see, there's a bunch of different things here. One of the things that we want to change is the gravity scale. If we don't change the gravity scale and I hit play, you're going to notice something. Apparently, you're not going to notice anything. That's different. Usually with gravity, it's gravity. Things are going to fall. So I'm not sure why that didn't work there. Maybe because I did update Unity. If you didn't see it in the other videos, I'm using 6.1. So maybe that's something they changed. I don't know. So just to be safe, though, we're going to change the gravity scale to 0. Collision detection. Discrete saves some memory space, and it does help on performance. However, that can cause issues on things that are going to collide all the time. So we're going to do continuous, meaning it's constantly, every frame, every second, every subframe, checking for collisions. This does use a little bit more power, but for objects like the player, who the player themselves are always going to see, you want to make sure that nothing bad happens, and you don't glitch through a wall or something like that. Again, we're not doing any animations, and there's nothing that the player is going to be able to walk into right now, so it's not going to matter yet, but it's just to save a step later down the road. The other thing that we want to do is we want to do this little drop down for constraints, and we want to freeze the Z rotation. Right now, again, it's not going to matter, but if you don't freeze the Z rotation and then you have something an object here that the player can walk into, the player's rotation will automatically move based on that object, and you don't want to do that, obviously, because you want the player constantly standing upright like this. Once that rigid body 2D is in there, we're going to add a couple things that we're going to use later. We're not going to use now, so I'm not going to really go explain them, although some of them are self-explanatory, like the animator. We want to add that. And we want to add, for now, one box collider 2D. Those of you familiar with Unity and familiar with doing this, you know why we added that stuff. Those of you not familiar, we will be messing with some of this stuff on the next video, and the rest of it a few videos down the road. So for now, just add them, but don't do anything with them. So now that that's out of the way, we can play with the input system. So there's two ways to do an input system. There's the new Unity input system, which is kind of confusing at first. I will openly admit it is confusing. Even now, sometimes I get confused with it. But it is the most versatile, and it's easier down the road whenever you want to have like players define their own inputs and things like that. The old system's still great, but it makes it a little bit more difficult for user-defined controls. So what we're going to do is we're going to go to our inputs folder. We are going to right-click, create a new folder, and we're just going to name this player. Then we're going to go into that player folder. We're going to right-click, create input actions, and we'll just name this player input. So I opened up my notes and it opened it up on the wrong screen. But what you're seeing there is what we're going to be doing. If this would just go over there, God, there we go. So we're going to double click on player input. And of course, that one opened up on the other screen. There we go. So if you've done everything correctly, you should have a screen that looks similar to this. So over here where it says action maps, we're going to hit the little plus, and it's going to add one in here, and we're going to name it. We're just going to name it gameplay. So we already have a new action because it automatically adds one. We're going to double click that, and we're just going to name it move. And then what we want to do, not the size that it's supposed to be, and it moved it over there. Why are you giving me a hard time? I recently upgraded to Windows 11, and I've had nothing but problems with some of this stuff since then. All right, so over here where it says action properties, we want to change the action type to value. Control type, we want to change that to vector2. Everything else, actually, we're just going to add normalized vector2 right here. Yeah, but everything else we're not going to mess with. So now over here where it says no bindings, we're going to right click and just delete that. And we're going to hover over move, right click on there, and we're going to add up, down, left, right composite. And it's going to create a 2D vector, which we shouldn't have to do anything with because it automatically did everything. And then we're going to click on this little drop down, and you're going to see up, down, left, and right. So if we click on up over here where it says path, you click on there and just hit W, and you're going to get a whole bunch of options, but we want W keyboard. For down, we're going to do the same thing. We're going to hit S, and then we're going to look for S keyboard. For left, we're going to click on path and hit A, and we're going to get A keyboard. And for right, we're going to click on that, and we're going to hit D and look for D keyboard. So in case you haven't figured it out, what we're doing here is we're binding the WASD keys to up, down, left, and right. Or if you're doing it in order, up, left, down, and right. Now that those keys are binded, we're going to right click on here and add another binding. And what we're going to do is we're going to click on path, go to gamepad, and just click left stick. You want to make sure this says gamepad. Some versions it does have like Xbox controller or whatever. If you do the Xbox controller, that's great. It'll work great with an Xbox controller. But depending on what aftermarket controller a player is using, it may not work correctly. Whereas a large majority of the gamepads and controllers that are on the market, it will be automatically binded correctly if you just use left stick gamepad. So now that all of that is done, we're going to go up here, we're going to click Save Asset, and then we can close out the player input. So if we click on this, you'll see all this fun stuff over here. It's really not necessary to do this now, but I'm going to do it anyway. Where it says Generate C# class, we're just going to click on that, and then click Apply. And it may open up your Visual Studio if you don't already have that open, but we're just going to shrink that for now. We're going to click on our player. We're going to go down where it says Add Component in the inspector. And we are going to now add player input. So we're going to click on that. And where it says actions, we're going to drag that player input that we just created. And we're going to drop that there. We want to make sure that all this stuff says what it says. Gameplay. So for the default map, gameplay. Behavior, for now, we're on send messages. And all this stuff should be empty. Once you have that done, we can actually script our first player movement script. So we're going to go to scripts. We're going to right click, create a folder, and name it player. And then in that player folder, we're going to right click, go to create, go to mono behavior script, and we're going to name that player controller. Again, for whatever reason, my Visual Studio automatically opened up, but it did not open up the player controller script. So we're going to shrink that real fast and then double click the player controller. And now Visual Studio should be up. And here is where we are going to get all the stuff we need for controlling our player. So I know in the last video we made the game manager and scene loader. I really didn't explain anything. But in this video, I'm going to try to somewhat explain things. Ideally, you would like to have some sort of programming knowledge before going into game design, game programming, and things like that. I'm going to try to make this as basic and easy to understand, but I'm not going to necessarily dive too deep into the actual programming aspect of things just because of the fact that this is not a C# beginner class. This is a game design, game programming class kind of thing. So some of this stuff is pretty self-explanatory. I'll admit, but some of it can get complicated. So again, I'll try to explain some things, but for the most part, ideally you'd like to have some programming knowledge. With that being said, what we're gonna do up here where it says using, we're gonna add another using, and we're gonna make it the Unity engine.input system. So anytime you have using statements up here, you're essentially using predetermined functions that are within those things that you're using. So like the Unity engine input system, that's the new input system that Unity is using. We are going to have to pull some things from there, so that's why we're using that. We're going to add a little safety check here, and we're going to require component. And as you can see, my Visual Studio is automatically trying to figure out what I'm trying to do here. It's somewhat right. We want rigid body 2D, not rigid body. But I'm going to hit the tab key to fill in that part. I'm going to hit the tab key again to fill in the rest. And then all I'm going to do here is just fill in the 2 and capital D. So what this is going to do is whatever component we put this on, it is going to check to see if there's a rigid body 2D. If there is not, none of this is going to work, and you're going to get a little error message. But that's just to make sure that we add that rigid body 2D. So now what we're going to do is we are going to add some variables. So again, those of you that have never programmed anything in your life, you may want to take a couple classes on programming first. But variables are things that we can manipulate and change. What we're going to do, though, is we're going to add a header for our variables, and we're just going to name it movement, and you'll see why we're doing that once we switch back over to Unity. We're going to serialize the field. So what serializing the field does is it allows you to take a private or protected variable and actually edit it within Unity. Again, I will show you that once we get there. So we're going to do a private float move speed. Go away. There we go. We're going to equal that to 4f. So that's going to be our default value for move speed. We will be able to change that in Unity. Again, for those of you not familiar with programming, there's different types of variables involving numbers. You're going to see a lot in my videos integers or int and floats. So floats are decimal numbers. Integers are whole numbers. So 0, 1, 2, 3, whereas a float can be like 4.1 and things like that. Again, you might want to dive a little bit into some programming classes first, but that's what that is. So now what we're going to do is a private rigid body 2D, and then we're just going to name it RB. That's going to be our reference to the rigid body. Then we're going to do a private vector2 move input. So again, vector 2 is 2D movement. So x and y. So x and y. So up and down, left and right. Vector 3 is 3D movement. So x, y for up and down, and then z for forward and backward depth of field, I guess. It's the best way to describe that. But since this is a 2D game, we're going to do vector 2. There are some instances where you can do a vector 3 in 2D, but for the most part, we're just going to be working with vector 2. So now what we want to do is we want to do a private void awake. My Visual Studio kind of automatically finishes for me before I can do anything. That's why I kind of accidentally typed some stuff in there. But what we're going to do here is we are going to link the rigid body to the actual rigid body without having to do anything in Unity. And as you can see, my Visual Studio kind of figured out what I wanted to do. So I'm just going to hit Tab to finish it. So like this is going to automatically grab the rigid body on the player and use it in the code here. Now what we're going to do is just some safety stuff. So we're going to do rb.gravity scale, and we're going to set that to 0f. And then we're also going to do rb.freeze rotation to true. So we already did this, but in case you forgot to do it, or for whatever reason when you're messing around in the inspector and you accidentally change one of these, this will automatically change those gravity scale and freeze rotation settings. Now what we need to do is we need to do a private void on move, and my Unity is going to, or my Visual Studio is going to freak out and make that on animator move. We don't want that. We just want on move. And then here in the parentheses, we want input value, and then just change that to value. And then we're going to do move input equals value dot get and vector 2. So when we created our move inputs, it automatically created code in the background. That was that C# stuff that we generated. This is going to automatically call when a movement is made. It's grayed out right now, and that's normal. That's fine. But we want to put that in there for movement. What we also want to do is put a private void on disable. And in here, we want move input equals vector 2.0. And then if rb not equals null. Now, for those of you that are, again, new to programming or have never programmed in your life, this is an if statement. So with an if statement, anything you put in the parentheses here, so this case rb, and then if you put an exclamation and an equal, that means not, and then null means not there, not existent, 0. You're essentially checking to see if this statement is true. If it is true, everything you put after this will happen. If it's not true, then either nothing will happen, or you can get what's called else or else if statements as well, where you can check to see if this is true. If it's not true, well, then you can check to see if this is true. If that's not true, then you can check to see if this is true. So you can have a really big string of else if statements, or you could do nothing, or you can say, hey, if this is true, do this. If it's not true, then do that. This is just a plain basic if statement. It's going to check to see if something is true and then do something. If it's not true, then it's not going to do anything. You can do an if statement like that in one line. So I can technically put the rest of this here. linearVelocity equals vector 2.0. And this will still run. I'm a little old school. I still like to put things in brackets. So there you go. This will run as well. It's literally the same thing as just putting all of this right behind this without the brackets. That brings me to my next point when it comes to coding. You want to try to keep this as clean and neat as possible. As you can see, I like to add a blank line above and below. For me, that's just a little bit visually appealing. It also makes it a little bit easier for me to read the code. If you're doing this by yourself, if you're an indie game designer and it's just you doing this, if your code works, your code works. That's the important thing. How it looks is up to you. If you're working with a team, get together with that team and figure out what they want to do, how it should look to them. That way, you're all on the same page. There is kind of like an ethics to it. And everyone was taught different. And then, especially if you know multiple languages, some languages are also different as far as how all this stuff looks. So make sure this is readable to you if you're the only one, or readable to your team if you're working with a team. The way I do things isn't necessarily the way you're going to do things. But again, as long as it all works in the end, that's what truly matters. So just keep that in mind. So what this onDisable is going to do is, if for whatever strange reason the PlayerController script is no longer running and gets disabled, whether it be because a scene changes or a condition in the game changes, it's going to make sure that the player is not stuck constantly moving in the last input you were giving it. And then whenever we animate, it's also going to not get the player stuck in an animation loop. Again, just more of a safety thing. Next, we're going to do the actual movement. So private void fixed update. And then in here, we're going to do rb.linearVelocity equals move input times move speed. Now that's all we need to do really for right now. There are some changes that we're going to make to this a little bit later. But let me explain fixed update real fast. There's an order of things. There's update, there's fixed update, there's a bunch of different things. But fixed update is where you want to put any type of physics. So any type of movement, any type of objects falling if you're doing a platformer. It makes everything just a lot smoother without going into too much crazy detail. So anytime you're doing any type of movement, not animation, movement, like moving an object or something like that, it is better to do it in a fixed update if the player is controlling it. That's another part that I want to put in there because that plays a big part in it. So if the player is causing that movement, such as the player moving, you want to make sure that's in fixed update. But now that that's done, we can go back to Unity. In our player, we want to take that player script that we just made, and we want to drag and drop it. As you can see, that heading movement that we made is right there. Since we serialized the move speed, that's right here, and we can change and edit this. And with all of that out of the way and done, we should be able to hit play. And we should be able to move our player. So I'm using the WASD keys on my keyboard, and I'm moving him. I do have one of the 8-bit the 8-bit dues controllers hooked up to my computer, and now I am using the left stick to move around. No other buttons work. Arrow keys don't work. Nothing else is working right now except for what we wanted to work. So that is how we get player movement. We can add the arrow keys if we want to add the arrow keys. If you're using a controller that has analog up, down, left, right, then you can by all means add that as well. But for the most part, we're using what we want to use. If you see this little star next to test scene, that means you have not saved the scene yet. So Control S to save that, and now that goes away. And that is it. That is everything for player movement. In the next video, we're going to animate the player. And then in the coming videos after that, we're going to actually start building a world for the player to move around in. With that, I'm going to end this video here. Please subscribe, as I have videos like this coming out all the time, and I do not want you to miss anything. Don't forget to give this video the big old thumbs up. Stuff like that will help. Not only will it help me, but the more thumbs up, the more YouTube likes the video, the more it pushes out to others that may want to learn. The challenge that I'm going to give to you guys is to play around with this. You can change the player speed. If you want to try to get ahead and you know how to animate, by all means, go ahead and animate. In the comment section down below, let me know if this was helpful to you. Let me know what settings work best for you. And if you want to just say hi, you can do that as well. But I'm going to end it here. So, thank you. As always, have a good one.